video, I'm going to talk about loop analysis in multi-source network. Multi-source means we have more than one power source. Let's say if we have a diagram like this, so we have the power source E1 and E2. This is the positive side for E1. This is the positive side for E2. So in order to use loop analysis, so we need to find the loop first. Here, by looking at the diagram, we have two loops. Here is loop 1. This is loop 2. So we have two loops. That means we need to solve two variables like I1 and I2. And we need to build two equations. So let's look at the first loop. So the idea is we use the KCL to help us build the loop equation. Okay, let's see. We start from E1, V equals I1. So the idea is when we define the direction of the current, usually we follow the positive side for the power source. So let's look at this one. The positive is here, so the current will flow this way. That's how we define the positive direction for I1. So this is I1. Same thing for the other side. The positive is here, so the current flow will be like this for I2. That's how we define the positive direction for I2. So for the loop 1, E1 will equal to I1 times R1, then plus I1 times R3. Then it's not just I1 flow R3, it's also I2 flow R3. And they have the same direction, so it's plus I2 times R3. That's our first equation. So if we plug in the number, let's say E1 equals 16, I1 is unknown, times R1.2 plus I1 times R3 is 1 plus I2 times R3 is 1. So if we simplify it, we get 16 equals 1.2 I1 plus I2. So this is our first equation. Now let's look at loop 2. So we start from the power source. That would be E2 equals I2 times R2. Same thing for R3. We have plus I2 times R3 and also plus I1 times R3. Because both I1 and I2 will go through R3. That's why we need to do the current for both. So this is our equation for loop 2. So basically if we copy that, E2 equals I2 R2 plus I2 times R3 plus I1 times R3. If we plug in the number, E2 is 12.8, I2 is unknown, times R2 is 0.1, plus I2, R3 is 1, plus I1 times R3 is 1. So if we simplify it, it will be 12.8 equals 1.1 times I2 plus I1. So this will be our equation 2. So if we put them together, so it's 1.2 I1 plus I2 equals 16, and 1.1 I2 plus I1 equals 12.8. This is 1, this is 2. Then we just use math to solve these two equations. We can get I1 and I2. I1 equals 15 amps and I2 equals minus 2 amps. Minus 2, when we have minus sign, that means the direction of the current I2. When we define it from right to left. So if we get negative sign, that means the current for I2, the direction is this way, from left to right. That's the negative sign means. So sometimes when we solve the equation, we could get a negative sign. That means the direction is opposite for when we define the positive one. So now we have the basic idea how we use loop analysis to do the circuit. So basically we look at the power source and find the positive direction. Then we define the positive direction for the current. And sometimes we could have more than 2 loops. This is the 2 loops, so we have 2 currents. So we assign I1 and I2 to it. Then after that, we need to build a loop equation by using KCL. So start from the power source, just the voltage drop after R1, and then the voltage drop after R3. But for R3, we have 2 current flow into it. So we have I1 and I2. That's why we need to put both current. When we look at the circuit, we look at the current separately. But in the real world, there's only one current flow, so it's I1 plus I2. And after we build the loop equation, 1 and 2, we can solve the equation by using whatever the method. We can use substitution, we can also use determinant, just a different method to help us to solve the equation. Then we can get the number for I1 and I2. So this is the example for 2 loops. If we have more than 2 loops, sometimes we could have 3 loops. So let's say if I have something like this, so one resistor here, so another one here, one more. This is our power, another resistor here. So here we will have three loops, one here, this is our second one, this is third one. So let's say this is the E1, R1, R2, R3, R4, R5, and this is our E2. That's assigned value to the power source and the resistor. So let's say E1 equals 15 volts, E2 equals 10 volts, R1 equals 2.2 kilo ohm, R2 equals 3.8 K, R2 equals 6.8 K ohms, R3 equals 5.6 kilo ohm, R4 equals 3.3 kilo ohms, R5 equals 1 kilo ohms. So here we have three loops and 2 power sources. So we can go ahead and define our positive direction of the current. So let's say this is the I1, and if we look at, so goes this way, and this is our positive side, so we do it like this. So this is our I2. For I3, we go this way. This is our I3 because this is the positive side. So this is our I3. Now we need to use KCL to build 3 loop function equations. So we need 3 loop equations. So let's say E1 equals, we look at loop 1, E1 will equals I1 times R2. We also have, so I1 is this direction, I2 is this direction. So if we use I1 as a positive side, then if I2 is facing down, so it will be minus I2 times R2. Then we plus I1 times R1. That's our first equation here. And for loop 2, we will have power source and R4, R3, R2. So E2, start from positive side, E2 equals, so we will have I2 go up. So I2 is this direction, I3 is also this direction. So we will have I2 plus I3 times R4, then plus I2 times R3. That's only one current source. And we plus, since we're using this direction, so it'll be I2 minus I1 times R2. That's for the current flow R2. They in opposite direction, so we use the positive side, subtract the negative side, then times R2. So this will be our second equation here. For loop 3, if we look at the diagram here, we have power source, we have R4 and R5. So same thing, E2 equals, so I3, the positive direction is this way, so we have I3 and I2, so it will be I2 plus I3, same thing, times R4, and then we plus I3 times R5, because there's only one current flow to R5, and it's just I3. So this is our third equation. Now we have three unknowns, which is I1, I2, I3, and we also define the positive direction. So now we just need to plug in the numbers and solve the equation. We can find I1, I2, and I3. Let's say, so 15E1 equals I1 times R2. $6.8, then minus I2 times 6.8 plus I1. R1 is 2.2. So that will give us nine times I1 minus 6.8 times I2. So this is our first equation here. Now for the second one, E2 is 10 volts equals. So for the first, this is our first equation. For the second equation, 10 volts equals I2 plus I3 times R4, which is 3.3 kilo ohms, and then plus I2 times R3, 5.6. Then plus I2 minus I1 times R2, 6.8. Now after we simplify it, we could get negative 6.8 I1 plus 15.7 I2 plus 3.3 times I3. So this will be our second equation here. This is our first one. For the third one, just plug in the numbers. We have 10 volts equals I2 plus I3 times R4, which is 3.3, plus I3 times R5, which is 1 kilo ohm. Now we have all the equations here, 1, 2, 3. So basically 9 times I1 minus 6.8 I2 equals 15 minus 6.8 I1 plus 15.7 I2 plus 3.3 I3 equals 10. We also have I2 plus I3 times 3.3 plus I3 equals 10. So we have equation 1, 2, 3. Now we can solve for I1, I2, and I3. After we solve the equation, we will get I1 equals. So after we solve the equation, we can get I1 equals 2.95 milliamps, I2 equals 1.7 milliamps, I3 equals 1.02 milliamps. Since we get all positive numbers, that means the positive direction is the same as predefined. Alright, that is everything for today's video. Thank you for watching.